Hello everyone, this is Abid. Today we're going to talk about types of levers. So, what are levers? Levers are simple machines that we use to lift our objects. Like whenever we lift an object, we have to go it up. But whenever we do it vertically, like this, we have always played a thing called seesaw. Force is pushed here, and the object goes up. That is how we lift an object. But it has many types and has many kinds of uses. For example, class 1 lever. What is a class 1 lever? We see that this first is here is the force, and this here is the load, and in the middle we have the fulcrum. See, this is a class 1 lever because the fulcrum remains at the middle. But if the force was exchanged force, nothing will change. But if fulcrum changed to force, then something will change. Like class 1 lever, we have fulcrum in the middle. It is also a simple machine. Class 1 levers like scissors. Whenever we cut, we hold a part. Like, let's show you a scissor. Let's suppose that this is a scissor, and we all see that whenever we cut using a scissor, we put our hands in the circle. So this is the fourth arm, and then we have a middle point which connects the two parts of scissors into cutting paper or cloth using the lower arm. Oh yeah, I did not talk about fourth arm and lower arm. So you see this part here is the fourth arm, and the rest of the part is known as lower arm. So yeah, we understood that the class 1 lever fulcrum remains at the middle. But what about class 2, class 3? Exactly, we're going to learn about those. So let me finish class 1. Mechanical efficiency. What is mechanical efficiency? Mechanical mechanical efficiency is the amount of force that is needed to lift an amount of a certain amount of load. So the mechanical efficiency formula is load by force. In short, we'll say it as ME, mechanical efficiency. Now, to increase the mechanical efficiency of a class 1 lever, we have to do certain things. Oh yeah, the another thing is that the mechanical efficiency of load and force can also be length of the force arm by length of load arm. You see, now we know that the force arm is here and the load arm is here, but how do we actually increase the mechanical efficiency? Let's say that the force arm is 4 meters and load arm is 2 meters. So mechanical efficiency of it will be 4 by 2 meters equals to 2 meters. There will be no meters because it's a ratio, and ratio of the same quantity do not have any kinds of units, so it will be 2. But what if we want to turn it into 3? So to do it, we have to do the following things. At first, we have to decrease the load arm, or we have to increase the force arm. Because you see, if we decrease the load arm, let's say load arm is 1, then it will be 4 by 1. So yeah, you see, it is definitely bigger than 2. Or let's say that this is 2, but this became 3. Another type of equation we have here. So 6 by 2, we have 3, which is also bigger than 6. Sorry, bigger than 2. So yeah, by increasing the force arm and decreasing the load arm, we can get the mechanical efficiency increased. Now, what about the other things? Now let me erase class 1 lever. Now we have class 2 lever. Now class 2, we learned that in class 1 lever, the fulcrum, the middle point remains in the middle point. But this time we have another problem, because you see the middle point is not in the middle point. Instead, it is in the side. This is the fulcrum now because it's the middle point. But you will say, Abid, that is not possible. But yes, actually it is possible. Let me show you with a practical one. Whenever you go to a tea stall anywhere, you will see a nut cutter. We eat betel leaves and betel nut, but betel nuts are hard. How do we cut them? Using nut cutters. But did you ever notice that the fulcrum is here, not in the middle point? And the load is in the middle point. The nut which we want to cut remains in the middle point, and we put force right here. So you see class 2 lever, their load remains in the middle. And what about force arm and load arm? How do we do it? So you see we have to cross it. This part we have load arm, and this part we have force arm, and this part we have load arm. And fulcrum has no arm, so we do not have to think about it. What about increasing the mechanical efficiency? The mechanical efficiency formula remains as it is. Let's say that it is 2 meters and this is 4 meters. So we have 2 by 4, which is 0.5. Now let me give an equation. What if I want to get 1? We want 1 here. But how do we do this? By keeping the same amount of load. How do we do that? So to do this, we can do many things, absolutely many things. We can also do these for class 1 lever, like we know load. To get mechanical efficiency, we can increase load or decrease force, anything like that, but that is not what we need. Mechanical efficiency is the ease that we get, the ease while taking it. So to get ease, we need to increase force arm and decrease load arm. Same as every time, class 3 lever also same, but we have to increase this part, like 2 meters, 4 meters. No, we need to get 1 meter, we need 4 meters here, or if it is 2 meters, we can get 2 meters here by decreasing it 2 by. So 2 by 2, 1, we know it already, it has no unit. That's what a class 2 lever is. Class 3 lever. We know that in a class 1 lever, the fulcrum remains at the middle, and in the class 2 lever, load remains in the middle. So that must mean the force remains in the middle in class 3 lever. Exactly. So whenever you go to a restaurant or anything like that, you will see a kind of pincer. The pincer is the object where we take food, fast foods, sweets, cakes, anything like that. So whenever you see it, fulcrum remains here. But this time, load not there. Load remains here. And force, we give it here. Now, why do we get force here? That is the exact thing. We give force here to get the object up or the load up. Whatever you can say, same as nut cutter, we have to divide it. This part is load arm and this part force arm until the fulcrum. This part is actually force arm. So same as everything, we can do it 2 meters, let's say 2 meters, and we have 4 meters. So to get mechanical efficiency, you know what we have to do? 4 by 2 and we get 2. Now to increase mechanical efficiency, we can turn it into 1, or we can increase it to many number as we like. I have a little cough because it's the winter season, So yeah, these are things, but you can also do another type of thing by decreasing load arm. But how to decreasing load arm? If you decrease it more to the force arm, let's say it is here, then you have to use less force. You can try it at home. You can get a pincer and hold your forearm almost close to the tip and use it. You will see that it is very easy and you'll use less force. But this time we have not learned everything because we did not learn load and force. Load is here and force is the amount of pressure that we give. But to make a ratio, we need the same quantities. What if the load is a kg and we do not know what the unit of force is? Exactly, that is why I am here. So you see, in a mechanical efficiency, load cannot be kg, gram, anything like that. It will be Newton. Same as force, Newton, both Newton load and force will both be Newton. As a result, nothing will occur. So let's say that a person gives 20 Newton force to lift or break a 10, or sorry, let me find 40 Newton nut. Now, what is the mechanical efficiency? You know that load equals force. So load is 40 and force is 20. So whenever we cross it, make it equivalent, we get 2 by 1. So 2 is the answer. It has no unit because we have both we have both force and load as newtons. And whenever we get a ratio, there will be no kinds of units if both the components are same. So that is all for today. Thank you for watching and see you in the next video. Goodbye.